I'm Aja. The second slide is going to be hilarious because of that intro. We did not plan this, I promise. There we go. Forgot about that. So I work in DevOpsDays at Google. That's not what this is about. Before Google, I was a tester. I was also a product manager, a program manager, a release manager. I racked servers. I carried a pager. I didn't really pick a major other than computers are kind of rad. So while my resume looks like there was a plan, there was very much not a plan. I just kind of took what I just followed my bliss and went a lot of directions. And currently, that direction is software supply chain. So because I'm a tester, I kind of started my career there. Once a tester, always a tester. This is a talk about problems. I'm going to talk about how we break stuff, because breaking things brings me a great deal of joy. If it doesn't bring you joy, well, maybe you can steal some of mine vicariously from the stage. This talk is not about solutions. I had a couple people proofread this talk, tech review this talk, and they're like, hey, you might want to put something happy in this talk. So there's a tiny, tiny bit of hope that I added at the end, small amount. But I just want to make it super clear. This is not 10 ways to secure your software supply chain. You won't believe number 8. I am definitely not here to sell you anything. There's not really any product mentions in this talk. I'm here to get my nerd on about all the ways software is brittle and vulnerable. I'm here to marvel at the ingenuity of hackers, or kind of collectively roll our eyes at how not smart you have to be to do a lot of these things. Because there's a lot of ways to break a supply chain, and they are amazing. So before we can talk about supply chain, we have to agree on what that is. And if Twitter on Sunday night was any indication, we don't agree on what that is, as I got into a Twitter fight. I'm going to define software supply chain my way. And if you disagree with me, my Twitter handle's on the bottom of the slides. Please do. We can get into a Twitter fight. I'm a fan. Or you can come disagree with me at a break. Because I'm a tester, I do think in systems holistically. It's just kind of how my brain is wired. So this is what I think of when I think of a supply chain. A lot of people are going, no, this can't be a supply chain, there's too many things. But let's actually walk through this. So you start with some code on your dev environment, you're tip-tapping away, writing some manifests, doing your nerd thing. Ideally, you're using source control. Please use source control. Checking stuff in and out. At some point, somehow, there's a build system and stuff gets built. Maybe you build it on your local machine. Maybe you have a third-party build server. Maybe you have a dedicated build server that's sitting in a data center somewhere, and you rack the servers yourself, and you have the bloody knuckles from doing it. Cool. Build system makes something that we're going to call an artifact. That could be a container image. It also could just be a folder of stuff you want to shove up on the internet. That's still an artifact. Somehow, somewhere, it gets deployed, and then it ends up in production. You'll be like, hey, why is production in your supply chain? I'll get to that. So if you know about software supply chain, you've spent a lot of time reading about it, or even a little bit, you're like, hey, Aja, you left out the most important part. I do not actually agree that it is the most important part, but you're right, I did leave something out. Let's make room for it. I left out dependencies. When people say dependencies in the context of software supply chain, what they're usually talking about is things like OS packages, language packages. Usually it's open source stuff that you pull in at build time. Turns out that's not actually inclusive, because there's a lot of other kinds of dependencies. Your IDE is a dependency. Your source control system is a dependency. Think about what would happen if whoever you use for source control, or your source control server, if you run your own, got compromised. Yeah, that would mess up your supply chain. Your production environment can be a dependency. What happens if your servers get hacked? And your deployment pipeline, your deployment tools can be a dependency, and we'll actually talk about another example of that. Also dependencies, people are dependencies, and I am not dehumanizing folks. I am just pointing out that if you have a malicious actor in your midst, your software supply chain is probably compromised, because people, we have to trust each other. So this is all great, and if you're sitting there thinking, you're like, oh, wait, all of my dependencies have their own supply chain. And all of them have dependencies that have a supply chain, and their dependencies, and their dependencies, and their dependencies. And it turtles all the way down. So now that we all agree on what the supply chain is, let's break it. I'm going to talk about some of the ways the supply chain has been broken, and in one case could be broken, and I'm going to show you all the parts of the supply chain that particular vulnerability or attack broke. It's going to be awesome. Let's start on the left with your dev tools. Why am I starting with your dev tools? Because we don't actually think about the fact that our IDEs are dependencies, or our editors are dependencies, or we run those open source packages and language packages that we put in production on our dev environments. And we could totally break stuff there. Well, also, your dev environment probably has access to source control, and depending on how rigorous you are, might have some juicy secrets that it can steal. There hasn't actually been a ton of research on this. There's been a tiny bit, but not a lot. And the reason there hasn't been a ton of research on that is thus far, I couldn't find any examples of giant terrifying data breaches or security incidents because of an IDE or a DevTools attack, but it could happen. And we're gonna talk about how it could happen. Most of the research has been on IDE extensions. Turns out your favorite IDE extension might be vulnerable. I think one of the reasons that IDE extensions have been the ones that are researched is, I don't know about you, I don't treat extensions as real software. I treat it as something that attaches to real software that I trust. Yeah, not gonna do that anymore after the research I did for this talk, and here, I'll show you why. So this is a super common pattern that researchers have found in IDE extensions that make them vulnerable. So you've got a dev env, you're tip-tapping away. You've got some sort of extension that starts up a local web server so you can test things. So you're doing that, you're testing stuff, got your nice tight dev loop going, and then a buddy sends you a cat meme. And cat memes are definitely more important than work, so you click on that link to go view this cat meme. It happens to be that that cat meme is on a malicious website. That malicious website is aware of the fact that it can ask for resources on localhost, on specific ports, usually in the href of a image tag or something like that. If they guess the port right, and your local web server is not secure, you can actually get to the point of arbitrary JavaScript code execution against your local dev environment. The phrase arbitrary code execution is one of my favorite and least favorite phrases. Whenever I see it, I get mad and scared. So this isn't actually a big deal if your dev environment is pretty locked down, but you probably, even if you're pretty locked down, do have source control credentials on your dev environment. Source control is compromised, everything to the right of it is compromised. These early pipeline attacks, can be super dangerous because it just trickles down from there. Again, hasn't happened, but it could. I just walked you through how to do it. So let's put some frowny faces on the parts of the supply chain we just broke. So we just broke our dev environment. We just, best case, likely compromised our source control. And the same thing could be true for our dependencies because they're open to the exact same issues as we are because they're likely using many of the exact same tools we are. Cool, let's keep going. System level dependencies. Yeah, these are fun. These are the ones that get their own logos because they're so big and terrifying. So who remembers this one? Raise your hand. Okay, I had a debate with a coworker. Who thinks this happened more than 5 years ago? Awesome. Who thinks this happened less than 5 years ago? I've got the CVE on the slide so you can actually figure out when it happened. This is actually 7 years ago. It feels like it was more than a decade ago to me. To a lot of my coworkers, it feels like it happened yesterday. So since most of you are familiar, won't go into details too much on this, TLDR, there was a vulnerability in a version of OpenSSL that lots of operating systems used. This was particularly pervasive and annoying because a lot of people didn't realize that they were using it because it just came with their OS, effectively. This isn't the kind of library that you have to purposefully include, so a lot of application level folks didn't know that they had this vulnerability. The other reason it was particularly bad, and these system level ones are particularly bad, is that they don't just impact your application. They impact your dev environment, potentially. They impact your build server. They impact your package manager's servers. They impact everything. And the reason this was called Heartbleed was because it was a vulnerability in OpenSSL in the heartbeat code. So I got one more of these. No points for guessing that it's this one. Again, fancy logo. Not quite as cool as the Heartbleed logo. Sorry if just seeing this makes anyone tired. I know it was a rough couple weeks. Much like Heartbleed, this was a zero-day exploit in a dependency that is, again, such a low level, most people don't realize they're even running it. Widely used library. The actual exploit mechanism on this one is pretty awesome. I'm gonna do my best to explain it, not actually a Java dev. So it was a particular Java library that handled logging, and how it handled string interpolation was the problem. You could put in a very specifically crafted payload and make it call out to an arbitrary server. Under the auspices of LDAP, but that didn't matter. It still made the call out. And as soon as you can make code call out to a server, send an HTTP request to a server that you did not intend, you're in a world of hurt. In this case, you could potentially put all the environment variables into the post body of that. You could put any other information you have access to in the post body of that, and they did. So interestingly, non-exhaustive research for this talk, this was the first time I saw significant, huge amounts of government, smackdown. You will get this fixed on this date. There was, an executive order about this. The difference between how the government responded to Heartbleed versus Log4Shell, night and day. 7 years, we've learned a lot. So let's see all the places we just broke. Awesome. So we just broke the build phase because that's where you pull in your OS dependencies. Great. We just broke servers because all of these are system level. As I said, your production environment does matter. It matters because the production environment for a dependency, specifically like a language package, is a server. So if rubygems.org or PyPI or someone was compromised at the production level, that's a production server, that could compromise your supply chain. But wait, there's more. Let's do the language packages. This is Ruby gems, NPM modules, etc. I'm gonna pick on Ruby. Those who know me know that Ruby is my friend. I'm picking on Ruby because the best stories were there. So this one, 2019, someone posted a gem called REST client. Hey, there's actually a gem. Someone realized, oh wait, that version has a backdoor added, some malicious code added to it. Ruby gems responded appropriately, locked the maintainer's accounts, pulled all the impacted gems, exactly what they're supposed to do. Upon investigation, what they found out was that the maintainer had been using the same Ruby gems password for about 10 years. It had appeared in a data breach because they had reused that password in another place. So someone just logged in as them and pushed a new version of the gem. They had lost access to their account. Ruby gems team was great, cleaned it up, fixed it up. And I have been told a lot of the language communities either have or are in the process of implementing required multi-factor auth for critical packages. There was an email that actually went out to Python folks about 2 weeks ago, 3 weeks ago now. Ruby gems has that too. But because this one exists, there has to be more. Similar story. In this case, a version of the gem got posted that was corrupted. Slightly different exploit mechanism, still old credentials, but instead of logging in and taking over the account of maintainer, someone logged in as the maintainer and just took over the gem. And it was found because someone was actually looking for the changelog for this update, because they pulled in this update with Bundler, and they're like, wait, this tag isn't on the GitHub repo. How did that happen? And then they realized that this had been posted maliciously, not by the maintainer. So those are fun ways. So maintainer credentials are a fun way to break your language packages. These are the boring types of supply chain attacks that happen all the time. Typo squatting, basically putting up a malicious gem that looks, or malicious package that looks like another package, a legit package. And brandjacking, putting up a malicious package that looks like it belongs to a well-known company or a well-known team. These are boring, so I'm only gonna talk real quick about two. The reason they're boring is there are literally thousands. They happen every day. It's an ongoing game of whack-a-mole. Package maintainers, package repository maintainers are doing everything in their power to fix them, and they're probably never gonna win. But two examples, CrossEnv, this was back in 2017 in the Node ecosystem. Turns out the actual package is cross-env. I don't know about y'all, I forget underscores, dashes, all those things in package names fairly often, so I could totally see myself getting bit by this. Someone put a malicious one up. Likewise, Python, it was request versus requests plural. This one was particularly insidious because a lot of packages other people relied on actually made this mistake. It was further down the chain. And the thing is, when people put up these malicious packages, when they're typo squatting or brandjacking, they will often wrap or otherwise make sure that their thing behaves appropriately so that you don't realize that there's a little bit of malicious code added as well. The other one I've seen is that they will only turn themselves on, the malicious code on, in production. They won't actually do it on your dev environment because they figure you're actually watching things more closely on your dev environment. So, supply chain breaks. Just tons more sad faces, lots of sad faces. So, lots of sad faces on dependencies. Compromised maintainer credentials means sad faces on your dev environment, just sad faces all the way down. It's just all sorts of sad faces. And the other thing I really want to point out, and I'll show this again, talk about this again in a bit, is in many cases when people do this and they inject this malicious code into dependencies, if at all possible, they will actually clean up after themselves as well. And so in a lot of cases, you can't necessarily easily tell if you were impacted until we figure out which versions of a dependency were impacted. So we'll do the fun ones now, and I am blasting through this, so clearly I was nervous. So one last type of compromise. These are the ones that make it on the news. These are when software providers are compromised, because software providers are dependencies in your supply chain too. So this one, can't skip this one, SolarWinds. So I'm not gonna talk about how SolarWinds itself was compromised. You can go look that up, not actually that interesting. But the basics of the actual compromise once the attackers got in was that they compromised the build system, which means they were able to inject malicious code into the builds that then SolarWinds distributed through their automated software update system. This compromised, in turn, the customers of SolarWinds. Unique in this case was there was a lot of really big companies and a lot of government agencies in particular were compromised by this. That, in turn, compromised the data of the customers of those companies. And again, transitive dependencies. The dependencies of your dependencies are also your dependencies, and this is one of the really good examples of that. If you start tracing it out, I'd bet a noticeable percentage of the world's population was actually impacted by this particular one in some way or another, just because of how many big agencies and how many big companies were impacted by it. Cool. This one's my favorite. Okay, so who's heard of this one? Awesome. I read about this one in January. So, what happened? There was a company making WordPress plugins and themes. They had a lot of them. They were popular. Someone got into their deployment pipeline and injected code into those WordPress themes and plugins, but only did it on some mirrors. So the WordPress.org versions of these were clean, but the versions hosted by other places were not. And it was only this company's plugins and themes, so it wasn't like someone hacked the mirror. They hacked this company, but they only deployed the broken versions some places. What they did is they threw a tiny bit of code, a couple lines in index.php, which starts up when WordPress starts up, opened a web shell, and then promptly cleaned up after itself, after doing its dirty business. Over 90 themes and plugins were compromised. So why is this one my favorite? My favorite because I didn't realize or think about the fact that a WordPress theme and WordPress themes, they're a dependency ecosystem just like Ruby Gems and just like NPM. It's a bunch of plugins, it's code, just like your IDE extensions. It's code. And the other reason I think this one is awesome is the person picking the WordPress theme and possibly even installing it, and the person doing deep analysis of your company's software supply chain, they probably don't sit in the same department. They probably don't talk to each other on a regular basis. And maybe we should. I summarize this attack when I'm talking to other folks at work and other places as, did you think your supply chain could get hacked because you chose the wrong shade of purple? Because that is kind of what this is. And it's amazing. And this was the thing that made me flip my thoughts about software to supply chain, to realize that there are so many dependency ecosystems that I don't think about as dependency ecosystems because I have a pile of biases because I'm a giant nerd. And I should probably get over those biases. So, one more, last one, I promise. We've talked about all sorts of ways to break the supply chain. So this one is another well-known good example, and I'm actually going to go into a little detail on this one. So CodeCub had a script, CodeCub does coverage, had a script using Bash that uploaded the results so that you could see trends over time, share results, all the normal stuff. That uploader, in turn, was used by plugins that people used with things like CircleCI or GitHub Actions or all sorts of places. So people generally didn't use the Bash uploader directly. They used other things that used the Bash uploader. A malicious actor added code to the Bash uploader. I believe it was a single line. It might have been two. You can actually go find the actual line on the internet. That copied the full environment variable setup out of any machine that it was run on, and posted it to the internet. This compromised many systems. So CodeCub did kill their Bash uploader, used NPM, and then you can go look at the CVE databases and see that their NPM version has had several issues. I'm not actually picking on CodeCub. I really wanted to call this one out because your CI/CD and build tools are if I was a malicious actor, and I promise I'm not, I promise I'm not, that would be where I would target. I would target that because they're running a lot. They're frequently running in environments that are privileged because your deployment system probably has access to production or at least some production resources. They do a lot of stuff that you kind of want to do as a malicious actor. They look at all your code. They upload stuff. Your build system's going to upload stuff. Your code coverage tool, of course it's going to upload results. So you're not going to think as hard if you see it uploading to, some random storage somewhere, right? Like that's what it's supposed to do. And so if I was a malicious actor, this is where I would target. And there are a lot of vulnerabilities that do target the CI/CD tools because of that. And as we're going to see, people are going to keep targeting them because it's just a very, very attractive and useful target. So last slide of my, very sad software supply chains. So yeah, there's just smiley faces all the way out because things like SolarWinds had huge ripple effects. CodeCov, impacted a whole bunch of people without realizing it because of dependency 1 or 2 levels down. It's just all frowny faces all the way down. Everything's awful. So with that, I'd like to close my talk, and we can talk about how, first of all, I have some time left, and second of all, I'm not gonna leave you with everything is awful in the supply chain is a disaster. Although everything is awful in the supply chain is a disaster, and it's amazing. I'm going to beg your permission to do a slight detour into chemistry. So here's a fun fact. I almost became a chemist, and then I realized if you're super clumsy, you should probably not spend a lot of time in chem labs because that's not a great idea. Also, there was this incident that I'm happy to tell you about at lunch with a quarter and some coin flips and stuff, and that's how I ended up in CS. But I like chemistry. I actually found it way more intuitive in physical chemistry in particular than physics or a lot of the other classes I had to take, sciences I had to take. So we're gonna talk about thermodynamics because as I research software supply chain, I think about thermodynamics a lot, and here's why. So these are the laws of thermodynamics. There's only 3. First one, the total energy of an isolated system is constant. Energy can't be created or destroyed. E equals mc squared means that matter also can't be created or destroyed, blah, blah, blah. Law number 2, any system which is free from external influences becomes more disordered over time. Chemistry word is entropy. You can think of it as disorder. I like to think of it as chaos. And if you are a chemist in the audience, I apologize. I am going to ruin these, but I'm promising I'm doing it for a point. And then the third law of thermodynamics is the entropy of a system approaches a constant value when its temperature approaches absolute 0. But I never actually remembered these versions. I certainly did not remember the versions with Greek letters and equations. I remembered this. You can't win, you can't break even, and you can't quit the game. So what do I mean by that? You can't win a shorthand for matter and energy are conserved. The total amount of energy stays the same, so if you maximize one aspect, you have to cut back elsewhere. You can't magic energy out of nowhere. It doesn't happen. You can't break even is short for entropy or disorder only increases over time. You can't get back to a previous state in time with less disorder. No time machines allowed. You can't quit the game is a little bit harder to explain, but the short version is the only way to stop that increase in entropy we just discussed is by reaching absolute 0, which we can't do. We can get really close and really cool stuff happens when we get really close, but we can't actually reach absolute 0 yet. So let's get back to supply chains. What does these rules look like in the context of supply chains? Well, you can't win. Energy is limited. We agree on that. We have a limited amount of energy. There's a limited amount of time. We have limited resources. If you maximize security in one part of your software supply chain, you're gonna have to loosen up elsewhere. You're gonna have to make trade-offs. You can't break even. You can't go back in time to a time when you didn't know about vulnerabilities or there were less vulnerabilities in the world. Sorry, vulnerabilities are increasing. And you can't quit the game. Theoretically, if you had no external dependencies and you never shipped any software, you wouldn't have vulnerabilities. But much like we can't reach absolute 0, absolute security is not a thing that is not a thing that we are ever going to be able to do, and it is not a thing that exists. So, awesome. Now, why'd you say that, Asher? Where are we going from here? Well, we've established that everything is essentially hopeless doom. And we have limited time, and new vulnerabilities are always happening, and security isn't something that actually exists in a relative sense. You should never, if anyone tells you that something is secure with no modifiers, do not believe them. So what do we do now? Do we give up? Well, no. Why would I be up here if we gave up? I promised you a tiny bit of hope, right? What do we do instead? Well, we do DevOps. What do I mean by that? Well, we take the skills we already have, and we apply them to the problem, just like we've applied them to production outages, to on-call rotations, to everything else in our DevOps lives. What does that look like? Well, we start by figuring out an error budget. Wait, no, not error budget, risk tolerance. We're gonna call it risk tolerance today. We sit down with our peers, our managers, everyone who has, who might be impacted, and we have a respectful, intelligent discussion about what trade-offs we're willing to make. We only have so much energy and time, so something is gonna have to get less energy and time. Should we pin all of our dependencies and never take updates unless they've been reviewed line by line? Maybe. Should we always grab the latest so we ensure that we get any security patches that are made? Also, maybe. Depends on your use case. But these are the discussions that we should have. And I really like this tool for having those discussions. People talk a lot about risk versus reward. I like just thinking about the risk part. This is a likelihood versus impact graph. Likelihood on the y-axis, number between 0 and 1. Think about it as a probability. Likely impact on the x-axis as a number between 0 and 1. That's a giant hand wave, but you get the point. So this point right here in the upper left, that is something that is high likelihood but low impact. Something's pretty likely to happen. So let's say that someone accidentally clicks a phishing link in an email. Gonna happen because human's gonna human, phishing attacks work, otherwise they wouldn't do them. But chances of that breaking prod, compromising your customer's information, pretty low. So this one in the middle is medium likelihood and medium impact. Maybe this represents something further up your supply chain being compromised. Somewhat likely to happen. There's a lot of dependencies that you have. There's a lot of pieces up your supply chain that you are using. But the impact may not be huge. A lot of these things can be mitigated pretty quickly. And then there's this one, low likelihood, high impact. This might be checking your production data